Please subscribe our channel Education Point and press bell icon to get notification of new educational videos.
Hello everyone, you are all welcome to lecture number 200 and still I am discussing that is called radio dating, and before I discuss carbon dating, that is isotope of C14, and now I am going to discuss that is potassium-argon dating and uranium-lead dating, and these datings are widely used, is very useful to know the age of very old, billion-year-old rock, soil, and for some archaeological purposes. For example, here the potassium 40, when it is converted to argon 40, it takes 3 billion years for that conversion. And when any rock, one of the oldest rock, when it is melted, and after melted, when ice and all those things are found, and in that you can get what amount of potassium is there and what amount of argon is there. So by comparing the ratio of K40 and AR40, you can conclude that the age of rock is 1 billion year, 2 billion year, or 500 year old. So that is used for that purpose. And in the same way, uranium converting to lead is also used for geological purpose, again to know the age of different type of fossils and rocks. Then the other one is called tritium dating, means tritium is the isotope of hydrogen, S31, and this the hydrogen, this tritium isotope is having roughly 12 year half-life time. In 12 years time, half of the nuclei is decay, and that's why this one is used only for knowing the age of the water, and even wine and beer. Wine and beer we can know, especially sometimes they claim that this beer is or this wine is 10-year-old or 5-year-old. So with that tritium isotopic dating you can know. So here the potassium, argon, uranium, lead dating, and that is also known as geological dating. Potassium, argon dating, the other isotopes can be used to date rocks, soils, or the archaeological objects that are much older. The potassium argon dating, for example, has been used to date samples up to 4.3 billion years old. Naturally occurring potassium contains 0.0118% by weight of the radioactive potassium 40 isotope. This isotope decays to argon 40 with half-life time of 1.3 billion years. The argon 40 isotope produced after a rock crystallizes trapped in the crystal. It can be released when the rock is melted at 2000 degrees centigrade temperature by measuring the amount of argon 40 released and comparing the amount of the potassium in the sample. The time since rock crystallized can be determined. The other one is that is uranium-lead dating. The age of Earth has been determined by using uranium-lead dating technique. And the sample of uranium ore are found to contain lead 20682. I mean the atomic mass is 206 and atomic number is 82, which is supposed to be formed as a result of series of alpha and beta decays of uranium. So this lead is found only after alpha beta decay of the uranium. In this method, it is assumed that the ore sample contained no lead at the moment of its formation. The measurement of the lead 206 and uranium 238 ratio will give the age of the mineral, and that will let you know the age of the earth or any other planet. Tritium dating. Tritium is S31, is an unstable isotope of hydrogen with half-life of 12.5 years. It is used for the short-range dating, such as finding the age of water and wine. So I have given one example for students just to show that how to calculate. There are standard formulae are given for half-life, time and decay. You just substitute the values, divide and multiply, you will get the end result. So here the example I have taken to calculate the age of the rock. That is, for example, a sample of uranium ore was found to contain 1.0 gram of uranium 238 and 0.1 gram of lead 206. What is the age of ore? Very common, very simple, straightforward question. And not only this question, all questions will be like that. Once they want from you to calculate the age of the ore or mineral or anything, you have to apply the same principle. And for carbon dating, you have to apply those formulae, which I have given you in that calculation. So solution is like this. The amount of uranium-238 decay will be equal to 206 gram. That is your 206 Pb is obtained from 238 gram of 238. Then 0.1 gram of 206 Pb will be obtained from 238 multiplied by 0.1 divided by 206. This is all atomic masses. It will give you 0.115 gram of U38. Hence, the amount of uranium initially present is equal to 1.0 plus 0.115 is equal to 1.1155 gram. We know that K constant is equal to, that is the formula you have to put here. K is equal to 0.693 divided by half time, T half, and that will give you 0.693, 4.5 multiplied by 10 to the power 9. That is the, here it is given, the half-life of uranium is given in hint. And then T will be equal to 2.303 divided by K log N0, Nt means initial nuclei and after decay. You will get 2.303 divided by 0.154 multiplied by 10 to the power 9, sorry, 10 to the power 9 log 1.115 divided by 1. And if you calculate all this, you will get 7.099 multiplied by 10 to the power 8 years old is the ore of uranium. So with this I will stop. Thank you very much.